The second design principle inserts in the blockchain system a consensus process that allows the participants in the peer-to-peer network to reach a collective agreement on the blockchain content. And that consensus process is called proof of work longest chain consensus, also known as mining. Let's explain this proof of work longest chain consensus mechanism. The main rule in this consensus mechanism says that the longest blockchain is the valid blockchain. Now, everyone in the peer-to-peer network is allowed to create a new longest blockchain, and the reward for doing so are newly created bitcoins and transaction fees. The result of these two elements together is that all the miners in the network will race to be the first to add a new block to the previous longest blockchain and create thus the new longest blockchain. Now, the conditions that have to be met in order for your longest blockchain to be accepted as a new longest blockchain and thus being used by others as basis to build the next longest chain on are the following. You have to be the first in the race and thus provide the quickest new basis for others to build a new block on. And your new block has to hold the following elements: valid transactions, the digital fingerprint of the previous longest chain, a valid auto-reward transaction, and a valid new digital fingerprint. Now, it's the computation process of that valid new digital fingerprint that is called proof of work, also known as mining. And that computation of the digital fingerprint requires huge numbers of complicated trial and error calculations that need important investment in infrastructure and energy. Now, because a new block includes the fingerprint of the previous longest chain, this proof of work is also an implicit vote for the blockchain on which you're building your new block. By consequence, proof of work is a voting system that uses investment in CPU or computing power as basis, with one CPU equals one vote. Now, if your block is invalid, for example because you inserted invalid transactions or an invalid new fingerprint, then no one will continue building on your new longest blockchain, which will become obsolete, and thus your reward transaction will not exist as your block will not be part of the new longest chain. So the beautiful thing here is that the voting process has an implicit incentive to do honest work. Let's have a look at the effects of this proof of work longest chain consensus on an aggregate network level. With the longest chain created through the fastest computing of proof of work, we can see that speed matters. A direct consequence is that an aggregate 51% of network CPU power is faster than 49% in executing the proof of work. At a global network level, that means that 51% of the aggregate proof of work power creates a longer chain than 49%. So that implies that the longest chain represents the majority vote, which becomes the blockchain truth. We'll see in the next slide why this is important. So you conclude correctly. If 51% of the network CPU or proof of work power participates honestly, then the longest blockchain will be truthful. And inversely, if 51% of the proof of work power participates dishonestly, then the majority vote as expressed in the longest blockchain will be untruthful. Let's repeat what happens on an individual computer level. So the computer that calculates as first the proof of work finishes as first the mining round, creates a new block and thus a new longest chain. And that new block and new longest blockchain is a basis for all the other computers to verify its veracity and use it to continue building on in the next voting round, or the next mining round, or the next proof of work round. The little graphics show that even if you're first to compute the proof of work, if your block content is untruthful, then it won't be used by others, supposing they are honest participants, to continue building upon, and thus your untruthful block and your reward won't be part of the longest blockchain. See you in the next video.